Hi everybody and welcome to this revision video on variables as part of Stage 2 Psychology Science Inquiry Skills, or SIS. Let's get started. So, we all know that psychology is a science, and psychology approaches the study of behaviour in a scientific way, of course. So we use the scientific method just like any other science such as biology, physics, or chemistry or geology. So the scientific method is the systematic approach for planning, conducting, and reporting research that involves collecting empirical evidence. So just like we go through a systematic or system, in other words, approach or method when we do experiments and investigations, like we do in other sciences, psychology is no different. There are different things, obviously, we have to consider, like ethics, but I'll talk about that in another video. The scientific method, however, is applied in psychology because, of course, it's a science. Now, the goal is that we obviously collect empirical evidence. So empirical evidence is data or information that's collected directly by observation or experimentation. So it allows the psychologist to draw accurate conclusions, which tend to be free of personal bias. In another video I'll film, I'll go through the different types of data that we collect. That's called research methods. However, the goal is that we collect empirical evidence so they're as accurate and reliable as possible following a systematic approach of the scientific method. So the first thing or the first step is deciding our variables and considering other variables that may affect our independent and dependent variable. So I'm sure that you've probably come across these terms before, but a recap never hurt anybody. So every research design or every investigation or experiment in psychology, if it's done getting quantitative data, so numerical data, has at least one independent and one dependent variable. So when we're gathering numbered data or numerical data, we always have a hypothesis and we always have to have at least one independent and one dependent variable. So the independent variable, or IV, is the factor that is deliberately manipulated or changed by the researcher to determine the effect on the dependent variable. So an easy way to remember the independent variable, I, what do I, as the researcher, have control over? What am I in control of? What am I manipulating? Whereas the dependent variable, or DV, is the factor that is measured as a result of the independent variable. It depends on the independent variable, hence the term. So often when we're trying to figure out what our DV is versus what our IV is, often it's easier to figure out the dependent variable first. All right, so what are we actually measuring? Okay, cool. Now what does that actually depend on? All right, and that way we can work out our independent variable. So what's affecting our results, in other words. So it's important in scientific research to operationalize our variables. So what this means is that we are specific, or we are being as specific as possible with what we are measuring. Now this makes it so it's able to actually be conducted as an investigation or an experiment. So let's go through an example. A researcher wanted to determine whether drinking caffeine or water makes athletes run faster. Okay, now we can easily identify the IV and the DV. So the IV is caffeine and the DV is time. So we know that the DV, or the dependent variable, is time because that's what we're measuring, and that depends on whether they have caffeine or not. So obviously that's what we manipulate, which is our IV, it's caffeine. So we can say to a group, okay, you're having caffeine, and then to our control group, we say, right, you're having water. We've got manipulation, we've got control as the researcher. And obviously the DV is what we're measuring, which is time. But we need to make this more clear for research purposes. So we just need to take it a step further. So we operationalize our variables. So using the same example as above, we would obviously operationalize the IV. So the type of drink, all right, water versus caffeine. So we're just being more specific, that's all. Then if we wanted to operationalize our DV, we would again take it a step further, pardon the pun, and obviously make it so it's testable, all right? And we're being more specific. So the time taken to run 400 meters, because if we just go back up here, obviously we know caffeine and time are just the basics, IV and DV. That's correct. But in terms of making that testable, it's a bit too vague as it is. So that's why we operationalize it, all right, to make it more clear for research purposes, okay? So the type of drink, water versus caffeine. So control group may have water, experimental group would have caffeine. And then we need to obviously set the time in terms of how, far they run, all right, and what would be appropriate. So just for this example, it's decided to run 400 meters. So 100 meters might be a bit too short. More than that may be too time consuming, or we may not get the quicker results, or it may not be as impactful in terms of the effect of caffeine on the body. So all we're doing when we're operationalizing our variables is making them more specific. Think of it that way. Okay, so there's other variables that we need to consider in science and, of course, psychology. So some of these you may have heard of and some of them you may not. So constant variables are factors that should remain the same throughout an experiment. So what do we need to keep constant, in other words? What should we keep the same to minimize any errors in our data? So if errors do occur, that leads us to these types of variables. So these are unique to psychology. These are called extraneous variables. We want to avoid these, all right, because they lower our accuracy and our consistency in our data, which is called validity and reliability. I talk about that in another video. But an extraneous variable is any factor that interferes with the data and has an unwanted effect on our dependent variable, or our results, in other words. So we try and control these as much as possible, but it's never going to be perfect, unfortunately, in psychology. Usually it can be too difficult, unethical, or just impossible to control every single one. So we will try and limit the extraneous variables in our research, but often that can be very, very tricky. So there are different types of extraneous variables. Okay, so there may be participant variables. So someone's biological sex, their intelligence, their personality, motivation, emotional state, cultural background, etc. So a variable that's unique to the participants that we're using that may be an extraneous variable that may have an impact on our DV. So we want a relationship. If I just go back for a moment, we want a relationship or a correlation or a cause and effect between our IV and our DV. So looking at this example, we want there to be some sort of a correlation or cause and effect or a relationship between caffeine and time. We want that. That's the whole point. What we don't want is another variable replacing the IV, because then we're not sure, is it the caffeine that's causing, the increased time in running 400 meters, or is it something else? All right. And the something else is an extraneous variable, to put it a little bit more simply. So is it a participant variable? All right, so their biological sex, their personality, their motivation, emotional state when they ran the race, for just as an example. We have to consider everything. Now, we also talk about the placebo effect, all right? We talked about this a little bit in Year 11 psychology, but this is the belief in the treatment working rather than the treatment itself. This is extremely common in drug trials. So a participant will be told that they are, taking a new drug or a new treatment to improve something or, make something better, but it is in fact a sugar pill, or it's, saline solution or something like that. But if they show an improvement in their results, or it's, seen to actually affect their behavior, that is called the placebo effect. So it's the belief in it rather than the actual drug working itself. So to put it into context, if we just go back here, we could tell our participants, yeah, you're drinking a caffeinated drink, when in fact it's not caffeinated at all, so it's non-caffeine. And if they then run faster and they attribute it to drinking caffeine, that is the placebo effect. So it's not the actually caffeine that's caused them to run faster, it's the belief that they're actually drinking it in the first place. That's the placebo. Next, we've got experimenter effects. So the experimenter's influence on the results. So for example, being tired or moody or unwell, or bringing in their own bias. So it may be the experimenter themselves that causes an extraneous variable to occur. So if we go back to this example, all right, it might be that the experimenter was a bit tired, so didn't actually accurately take the time, for example, or didn't believe that this was a valid experiment, so didn't really take it seriously in terms of measuring the amounts of caffeine, or didn't give them enough, or didn't give them enough water, or didn't run the actual experiment enough times. All right, all of these are extraneous variables that reduce the accuracy. Next, we have demand characteristics. So participants behave in a socially desirable way to live up to expectations. So knowledge of this can be good, so we can behave according to what's expected, or it can be bad. All right, so we know what's going on, so we sabotage the experiment. So in other words, all right, people, or participants, I should say, will give socially desirable answers or change their behavior in some way all right, which is not realistic. That's called demand characteristics. So again, it can be good, so behave according to what's expected and what the rules are or the expectations are of the experiment, or it can be bad. So if our participants have a heads up of what's going on, they may deliberately lie, not to get good results, but just to sabotage the experiment because they obviously are aware of what's going on. And that leads to our results being inaccurate. Then we've got situational variables, so how the participant will react in the experimental environment. So the actual room or place or setting that the experiment is being conducted. So what's the situation, in other words? This is very, very applicable to something that we have or that we will talk about, which is sleep trials. So when someone sleeps in a sleep lab, we need to really take into account the situational variables because they're hooked up to EEGs, EOGs, and EMGs, which are all connected to, you know, the corners of the eyes, connected to the brain and connected to the body, and they're sleeping in a lab environment. That's obviously going to be factors, or, you know, it's going to affect their sleep in a way that wouldn't necessarily affect their sleep if they were sleeping in their own home or their own bed. So that's a situational variable that may impact the results. Okay, so that is the revision video on variables done. I hope you found this useful. As always, any questions, let me know.